So this brings us to our last logical operator, which is the biconditional. So what is the biconditional? Well, the definition of the biconditional is as follows. For P and Q propositions, this symbol right here represents the proposition P implies Q and Q implies P. So how do you read this bunch of symbols right here? A couple different ways. You can say P if and only if Q. Or, as some people do in shorthand, you could say P, and this is an if with an extra F in it, Q, which is shorthand for P if and only if Q. So notice the definition of this biconditional right here. So it's the proposition P implies Q and Q implies P. Well, we already know the truth table for P implies Q, and we could use that to figure out the truth table of Q implies P. And we already know the definition of and right here. So let's go ahead and try to figure out the truth table for the biconditional. So let's go ahead and do that now. So here we have P and Q, and I'm going to do some scratch work in the middle because I have a P implies Q and a Q implies P. So I'll do a bit of scratch work, P implies Q and a Q implies P right here. And at the very end, I'm going to have my P implies Q and Q implies P. So note that this thing right here is how we would represent that proposition right there using our notation that we introduced earlier. So let's go ahead and see if we can fill out this truth table right here. It might be helpful at this point to recall the definition of implication, or P implies Q. So let's go ahead and recall over here. If we had P and we had Q and we had P implies Q right here, the truth table for this guy looks as follows. So remember that we call this part the hypothesis, and we call this part right here the conclusion. And we had from the definition of implication that P implies Q is only false when the hypothesis is true and the conclusion is false. So in this case, we would get the following. The only time it's false is when the hypothesis is true and the conclusion is false. And since we also have a Q implies P over here, let's go ahead and write out the truth table for that, just because the variables are all flipped around. So let's also look at Q and P, and Q implies P. So once again here, this implication, the only time it's going to be false is when the hypothesis is true and the conclusion is false. So that's the only place that is going to be false. Everywhere else, it is going to be true. And that's going to help us be able to figure out our scratch work right here. And so in fact, well, we can actually just copy this column of this truth table right here down in this location. So this one is true here, the hypothesis is true, and the conclusion is false, so this is false. This right here is true, and this right here is also true. For this one, it's a little bit more complicated. I have to find out when the hypothesis is true, that is my Q, so I'm looking at this one, and my conclusion is false, so that would be this one. So it's false here. And everywhere else, it's going to be true. And we can go ahead and check that yes, indeed, that corresponds with this particular truth table. When they're both true, it's true. And we can see when P is false and Q is true, then Q implies P is false. And you can go through and check that yes, indeed, this is filled out correctly. So fantastic. I've done a bit of my scratch work. I've got this left-hand side of the and I've got that right-hand side of the and. So I can go ahead and start filling things in a lot more simply because all I have to worry about is this and operator right here. So on the left-hand side, I have a true, and on the right-hand side, I have a true. So this thing is true. And over here, I have a false and true. So that's going to be a false. Here I have a true and a false. So that's going to be false. And here I have a true and a true. So this is going to be true right here. So we've been able to figure out from the definition and our understanding of implication and what the truth table of the biconditional actually is. So indeed, if you wanted to write it compactly, you could say that the truth table of this biconditional is simply as follows. P, Q, P, if and only if Q would look like the following. Filling in the values that we've already filled in here. And you can see, if you stare at this just for a little bit, the only time this biconditional, this if and only if right here, takes on a value of true is when both the left-hand side and the right-hand side take on the same values. So it's only true when both sides are true or when both sides are false, and it's false otherwise. So that's an alternate definition, and that's actually the definition that Rosen uses. So what Rosen says is, and this thing is true if both P and Q take on the same truth values.